Hi, in this video we're going to work on graphs of two functions and the relation with the solutions of these two. So first of all, let's remember that we have y equals f of x, right? This is a function and we can draw the graphs of functions, right? If we were to have f of x equals 0, we can just find out where the graph cuts the x-axis, basically, because we are just saying that here y is 0. Y is 0 means the x-axis, right? So we're just trying to find where the graph cuts the x-axis when we say y is 0. So this is very important, finding the roots of a function, right? But generally speaking, technically, we could go like f of x equals 2, for example. If I'd like to solve this equation, this means that I am trying to solve the equation where the graph cuts y equals 2. So the solutions will be these 3 points, right? So it depends what you write in here, right? If you were to write another number, then you would draw another horizontal line and so on, all right? But particularly important is that we find the solutions for y equals 0. But just that, we can now actually write down any number. We can also write another function there, right? So basically, we can go like f of x equals g of x, where let's say f of x is this graph, this function, right, f of x, and g of x is, let's say it's a quadratic, right? So this is g of x. So if I write this equation, then the intersection points of these two graphs will be my real solutions. Now, if we have graphs, we could just make an estimate for the coordinates of those intersections, right? But this is out of our scope. What we're going to go like is that when we have f of x and g of x drawn, we could see that there are two intersections, meaning two real solutions. So this is what we're trying to deal with at the moment. Now, let's look at this example. On the same diagram, sketch the curves with equations y equals x times x minus 3, that's a quadratic, and y equals x squared times 1 minus x, that's a cubic function. And find the coordinates of the points of intersection. Now we'll come to that. Let us first have these graphs sketched. So for the quadratic, if y is 0, then we have x equals 0, or we have x minus 3 equals 0, where x is 3. So if I plot these points and sketch the graph, I'll get this. And for the cubic function, we have x equals 0 as a double root and x equals 1. So just because, if you expand it, you're going to end up with a negative x cubed, which is a is less than 0, which means a is less than 0. It's not going to be like this, it is going to be like this. So I'm going to draw this graph like, it's going to come, my apologies, it's going to be the other way around. It's going to be not like this, but it's going to be like this, right? So let me draw the graph for cubic function. So it's going to be a double root on x equals 0, and this means it's going to come from here and goes up like this. Now, you're going to ask how I know that these two graphs will intersect here. Why is it not that it goes like this? Well, or of course if it's a double root I can't do that, I can just go like this, right? Well, the reason is that a cubic function goes straight up faster than the quadratic function. So this is not the case. At some point they should intersect. So I'm not exactly sure that I can draw it like this and show that it's actually around 2 or 3, whatever the scale is, but I have to know, I have to show that I know that they are going to intersect, right? That is the point. So scale is not important, we're just sketching the graph, right? And all I need to show is that I need to know how many intersections there are, which in this case will be 3, right? So as for finding those coordinates, it's no big deal. I'm going to go like x times x minus 3, the quadratic, is equal to x squared times 1 minus x. Generally, this is not being asked, okay? But it's no big deal. I'll just expand the bracket, so it's going to be x squared minus 3x equals x squared minus x cubed. Now remember, it is very tempting to cancel out those x's, right? Don't do that. Any cancellation of that sort will result in losing one or two of the solutions, right? So do not cancel out anything, instead just collect everything on one side, equating it to 0. So that's what we're going to do. I'm going to take all these to the other side, and I'm going to end up saying that it's going to be x cubed. So you can see, okay, let me write this down first. X cubed minus x squared, I took these to the other side, plus x squared minus 3x is 0, and minus and plus, these cancel each other out. I'll have x cubed minus 3x equals 0. Now, here, I can take x out, and I'm going to end up with x squared minus 3, right? And x squared minus 3 can further be factorized to x times x minus root 3 x plus root 3, as if it's difference of squares, right? And here I can end up with saying x equals 0, x equals root 3, and x equals negative root 3, right? And each one of those x values must be substituted here or here, whichever seems easy, and then you're going to end up finding that it's going to be either 0 to 0, right, or root 3 to 3 minus 3 root 3, and negative root 3 to 3 plus 3 root 3. So basically this is this one, right? That's the origin, and it's this one we're talking about. So these are the coordinates that we found. Another example. Part A says sketch the curves. There's a reciprocal and the cubic. And then using your sketch, state with a reason the number of real solutions to the equation. This is a type of question we will see mostly, but in case they ask the coordinates, that's what we're going to do in the previous example, right? So let's start sketching. So y equals 4 over x squared will look like this, right? This part is fine, but it's not going to be here because it's x squared. It's going to be here, right? So this is y equals 4 over x squared. As for the cubic, so it's going to be, so let me get rid of this bit. It is going to be y equals x squared times x minus 3. Now there's a double root in 0, so I'll go like x squared is 0, so x is 0, and x minus 3 is 0, so x is 3. So if I go like 1, 2, 3, let's say, right, and there's one root here, there's a double root here, and you can see that we end up with an x cubed. This means a is positive, so it's going to be like this. So this is the graph. I'm going to come from negative, say, infinity, and I'm going to go like this. Now you can see that there's only one intersection here at this point, right? And if I was to solve this equation, I mean this is equal to this sort of equation, then I would only end up with one value for x. So this is the sketch. It's very important that you write down the functions on top of the graph. So it's x squared times x minus 3 here. And part A is done. Part B, using your sketch, state with the reason the number of real solutions. So in part B, I'm going to write down there is only one real solution because there is only one intersection. Certainly, I mean, this is just the phrases I write here. You're going to write a nice sentence out of it, right? So this is pretty much it. And just because it's about drawing graphs and everything, there is no online self-check for this video. So please take your notes and then proceed with the exercise set from your textbook where I mention them in the blog. Thanks for watching.